So the cosine of 60 is the adjacent over the hypotenuse. So what is the adjacent to the 60?
Adjacent to the 60 would be 1,
Okay, so it's 1 over, and what's the hypotenuse?
2.
2.
Well, then how do you get the cosine of 30 degrees?
So you go up to the other angle here. So the
Oh,
other
then
angle,
it has to equal 180 to try.
well, yes, exactly. So the other one is, so in this case, the cosine of 30 is the
That would
square root
equal
of 3 over 2, like that. So it looks like that's the right answer.
5. All right, here's the next one, the chat. All right, the next one's on the chat.
Cool. All right, if 0 is less than b is less than 90, and a cosine 11b plus 12 equals sine b minus 4, what is the value of, okay. Um, so there's these cofunctions. So like the way the cofunctions works is, for example, the cosine of theta is equal to sine of 90 minus theta. But I don't think that's what this is wanting you to do. Okay, sorry. So there is exactly one place where sine equals cosine, and it occurs in this type of triangle, a 45, 45, 90. All right, so in a 45, 45, 90, sine equals cosine. So I think you're just setting these equal to each other. Like you're literally just setting 11b plus 2 equal to 12b minus 4.
Got it. And then you just solve for B.
Yeah. So why don't you do that for us, please?
B. Yeah. I got B equals 6.
Okay, that is correct.
Okay, so this is the other question that I have. I was kind of confused on this card or not, but it's in the chat now. Number 7.
Right. Okay, so this is that co-function that I was telling you about. It's that if this is 32, if sine is 32, and this is, we'll call this theta, then cosine is 90 minus theta. So it's cosine of 90 minus 32.
What we have. Nice work. 32 is 58. So it would be, oh, got it. So it's close. Got it.
That would be 58.
This is what I want once I have a question on the chat.
Okay. All right, so if sine y equals cosine x, which of the following statements is true? Okay. So just because the sine, and we kind of looked at this yesterday. Let me draw again. Let's say this is x and this is 3, 4, 5, and this is x over here, and this is 6, 8, 10. The sine of x is 4/5. The sine of x is 8 over 10, which reduces to 4/5. But these are not the same triangles. They're not congruent. So they're not congruent, but they are similar. They are similar. So when we look at the answers down here, that's kind of where I was going, is we got to get the ones, okay, which ones are similar. So for the similarity is the same here. So it's either y equals x or w equals x. So if sine y equals cosine x, then the angle must be the same. So these angles must be the same.
So y is the same as angle x. So y is so it'd be number 3.
Yes. Sorry, I know sometimes I don't give you the answer.
So yeah, so it's y equals x, and it can't be the first two. So then, yeah, the third one's the other one that says that has the y is equals 5. All right, here's number, and what's the question? Confused. We're at. Can I look over number 10? Okay. Yeah, I'm gonna try number 10. Okay.
Okay, so in triangle JKL, tangent of B is 3/4. So when you're standing here at B, tangent of B, which is 3/4, means it's the opposite over the adjacent. The
So it's
opposite
4/5 because
over the adjacent.
tan, because the tan is opposite over adjacent, and the sine is opposite over hypotenuse.
That's right.
And the
So you,
cosine is adjacent over hypotenuse. So
right.
actually, no, wait, it wouldn't be 4 or 5 because, oh, wait, right. Forgot that you're dilating it by a scale factor of 3.
Now that doesn't matter. We just saw that when you, even if you dilate, even if you make it bigger, it still reduces down to the same sine, cosine, and tangent.
Oh, got it. Yeah. I think that's what confusing because I tried multiplying it by 3, but I guess if you reduce it, you would get the same. So it'd be 4.
So now you gotta figure out which of these is correct. Could cosine be 3/5, 4/5, 5/3, or 5/4?
Opposite cosine adjacent over hypotenuse. So 4/5. Perfect. All right. All right. Next step is 5.2. Show this one. Here's the next one. This is a 5.2, which is trigonometric ratios.
Okay. All right, the post office is the corner of First and Main Street, which forms a right angle. First Street intersects with Oak Street to the north, and Main Street intersects with Oak Street to the east. The intersection of First Street and Oak Street form an angle, from X angle, and tangent X equals 7/5. Car drives on First Street for 10 miles to arrive at Oak Street. How far will car B have to travel on Main Street to get to Oak Street? All right, so the hard thing here is actually drawing the picture here. So it says the post office. I don't even know where to start here, so we'll just call that the post office. Is at the corner of First and Main. Main Street intersects with Oak Street to the east. So let me see if I can just, this is Main. This is First, and this is Oak. Let's see if that right. The intersection of First and Oak forms an X degree angle. And the tangent of X is 7/5. That means this is 7 and this is 5, like that. But that's just the ratio. So it says car A drives on First for 10 miles to arrive at Oak Street. How far will car B have to travel on Main Street to get to Oak Street? Okay. I know this is really confusing. Um, so the two sides here are in this ratio, 5/7.
Got
That's
it.
probably the better way to.
Yeah, the angle up there is X.
Yeah, we actually don't need the angle, but that it is good that it has. So when you go 10 miles though, drives on First Street for 10 miles, that's instead of 5, it's really 10.
Got it.
So what that means is you're doubling,
Um,
and then you're doubling 7 to become
14.
14.
Wait, actually, if you, oh, yeah, times 2, that'd be 14. I was thinking of 7 times 7, but 7 times 2. So yeah, that'd be 14. Uh, 14. This is one of the ones I wanted to chat in the chat.
You. Which equation could be used to find the value of x? Okay, so the value of x is this length over here on this side. Now, you always go to the given angle. You start at the given angle and you ask yourself, what are these relative to the given angle? And your answers are they could be the opposite, they could be the adjacent, they could be the hypotenuse. So what do you say? It doesn't matter which order is 55, which one of these three is the 55, which one of these three is the x.
55 would be the hypotenuse.
Good.
The
And then
opposite would be x.
good. All right.
And yeah,
So
the
which trig
adjacent,
function do you use? Which trig function uses the opposite and the hypotenuse?
the opposite hypotenuse would be sine.
Okay. So the sine of 49 equals the opposite over the hypotenuse. So what goes on top, what goes on the bottom?
Opposite would be x. So opposite goes on the top, and then hypotenuse goes on the bottom.
Okay, so what goes on the bottom?
Hypotenuse.
And give me the value.
Oh, 55.
55. Okay, yeah. Like sometimes we're saying the right thing, but like you could have told me anything, so I want to make sure you say that. And then you can see that that matches up with what you
Right.
have there.
Perfect.
So very good.
Um, Here's the next one that I got one. Let me put in the chat.
All right, what is the length of AD? Round your answers to the nearest hundredth. So where is AD? Okay, AD is down here. All right, so sometimes it's good to kind of just draw the triangle that you care about, which is this one here on the bottom. This is 3. This is 31 degrees, and we're interested, and I'm just going to call this C for the hypotenuse. Like that.
Got it.
Is that okay?
Yeah.
All right, so the hypotenuse is is what we're trying to find. What is 3 relative to this angle? Is it the adjacent or the opposite?
The opposite.
Yes. So it's the sine of 31 equals 3 over C. Now the question is, we haven't done one like this, but it's like, how do you get the variable out of the bottom? How do you get the variable out of the bottom? And the way to do that is to actually multiply both sides by C. All right, so to do that, you cancel C times sine 31 equals 3. And then you divide both sides by the sine of 31. Now, very important here, this is the first time we've had to talk about this. You want to make sure your mode in your calculator is in degrees. There are 2 modes for calculators, degrees and radians, and you want to make sure that they are, that it's the way you expect it to be.
So in degrees.
In degrees, yeah.
Got it. Yeah, I see that.
So if you're using that Desmos Scientific, that's great. Just make sure you see this, the degree symbol. I don't know what kind of calculator you've been doing. I mean, you want to be careful not to use the ones on the phone. They don't work as well as
Yeah, I'm just using the physical like
oh, good,
TI-84
good.
calculator.
That's even better. If you need help going to mode, let me know. I'll help fill you in on that. But give me just a moment, please. Be right back.
And no problem.
I'm back. Did you get a number for this, Karthik?
Oh, sorry, that's not me.
Yeah, just
For that
did you get a
one, no. Oh, do you want to put my cut? Oh, there it is. So it's I got 5.82. I got a small 5.82
that is correct.
rounded off.
5.82 is correct.
Yeah, I just rounded it off. But, there's one places. All right. Just please forward up my bit in the chat.
Thank you. In triangle JKL, solve for X. So just like in the previous problem here, you got to go to the given angle and you have to identify what's going on here. Like what is 34 and what is X?
34 would be the adjacent
Yes.
and
And
x
the
is
X
the
is the hypotenuse.
hypotenuse.
So which trig function uses the adjacent and the hypotenuse?
I think it's 10. Is the adjacent use of the cosine.
No cosine. So cosine of 27 equals what goes on top, what goes on the bottom,
Uh, ad- Adjacent goes on top and then hypotenuse goes on the bottom.
right? So what is it? What do
So
I put in
it's
this top position?
34 over X.
Yes, okay, good, good. Now,
Mm,
I'm laughing just because it's like there's a weird communication thing that sometimes happens over
Yeah,
Zoom because I can't see you to know if you're just like, yeah, you know. All right, so why don't you try solving this like we did in the last problem and see what you come up with, please. It's exactly the same, just different numbers.
I got 31.16.
Yeah, nicely done.
This one.
All right, so you dropped another one in the chat here.
Yeah.
Given triangle ABC, which equation could be used to find the measure of angle B? All right, so angle B is down here at the bottom. And you have to decide, you know, which of these is correct, basically. So for cosine, as you know, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse.
Yeah, because I thought you would use cosine, but then there's something that has like 6 over 3
Right, so
over
it's got to match up.
5.
And now there's a little bit other thing going on here. There's some what's called rationalization. So let's actually, why don't you find or tell me what goes for cosine and sine of B?
Cosine would be 6 over 3.
3 squared 5. Good.
5.
Okay, now to rationalize this, you have to multiply the top and bottom by root 5. So what that does is it makes 6 root 5 over 3 times 5 like that. Okay. Have you seen that before, that rationalizing stuff?
Yeah, I think
Or
I
is that,
have.
or is that totally new?
I think I have, but I don't
Okay.
remember.
So this becomes, it ends up being 2 root 5 over 5.
Got it. You have to rationalize it and simplify it down to can't be simplified anymore.
So that looks pretty good. I mean, that one appears to be there.
Yeah, 210, 2 squared 5.
You know, we got lucky. I mean, it's 3 over 3 root 5. You know, this one ends up rationalizing. If you do the rationalizing here, which is kind of the same thing, multiplying top and bottom by root 5, you end up getting 3 root 5 over 3 times 5, which ends up being root 5 over 5. And that one is not there.
All right. So here's the next one. Okay. Number, yeah, number 9.
Two airplanes leave the airport. Plane A departs at 44-degree angle from the runway, and plane B departs at 40-degree angle from the runway. Which plane was further away from the airport when it was 6 miles from the ground? So there's two triangles to draw here. So the first one is for plane A. Sorry, put plane A up here. 6 miles from the ground is that distance, the height, and then that's 44 degrees. And then the other triangle is for B is 40 degrees. And it's also 6 miles. So we're asked for which plane was further away from the airport. What's unclear is if they mean the X here or the hypotenuse. Let's presume they want the hypotenuse for a moment. So for A, it's sine 44 equals 6 over C. And for B, it's sine 40 equals 6 over C.
Okay. So then you have to multiply by C on both sides.
I guess calculate these. Maybe one of them will stand out as being
All right, I'm gonna
one of
try
the answers. If not, it will have to do a different trig function to find the
for the sine of 44. I got C would be 0.110.
well, you have to solve for C though. Like we want C. C is 6 divided by sine 44.
Oh, oh, sine. You just put it in. Oh, that I got 0.69
Hang on.
after doing. Actually, no, the sine of here and yeah.
So then the other one is 6 over sine 40.
All right, so it's not the one on the left. So let me try the one on the right. Sine. Yeah, it's the one on the right. It got 9.33.
So it looks like it's that one.
Yeah. All right. This last one kind of confused me because we haven't talked about another term that talks about in this one. SEC. So it's in the chat now.
All right, if secant x equals 5/3, what is the value of B? So this one's difficult because secant x, we don't know anything about, but we know that secant is really 1 over cosine x. Okay,
Wait,
so if you
so
flip,
C is 5 is the reciprocal of the
yeah, so
cosine.
if you flip the one on the fraction on the left, you flip the fraction on the right.
Uh, oh yeah, then it becomes cosine over 1 should just be uh,
Okay, so now the cosine x is the adjacent over the hypotenuse. And sometimes what you do here is you label the sides, like this is the 3 side and this is the 5 side. Is that clear?
yeah.
Okay. So the 5 side times 4 gets you to 20. So 3 times 4 is 12, and 12 equals the 3b.
B equals 4 because B divided by
Yep, so b equals 4. You
3.
got it. So
All right.
you have to do something to
I think I was kind of confused about what it meant by S or seek of X equals.
SCC.
Yeah,
So there's 6 trig functions, and let me I think I've sent you this reference sheet, this trig cheat sheet, but let me send it again here. Maybe I didn't send it over. There's all these formulas you need for trigonometry. And I know you're in geometry, but this ooh, that's not what I wanted. Copy link, chat. Cut. Okay, there it is. What is going on? Okay. Sorry, the nothing's working. Enter, you want that. Okay. So there's 6 trig functions here. And let me snip those in. So the angle here, the angle here is what they're referring to when they say opposite, hypotenuse, and adjacent. So it's relative to this angle, but there's sine, cosine, and tangent, and there's these other 3. Now, sine and cosecant go together. They are reciprocals, and that's another kind of thing that you have to know in this course. Same with cosine and secant, they are reciprocals
got it.
like this. All right.
Got it. All right.
So that's what's meant by that. So like the best thing to do is to flip it into something you do know. Sine and cosine and tangent are what you do know. Those are the ones to um,
Got it. All right. And next one. This is the next. So we're done with that lesson now. So now
okay.
we're on 5.3, which is applying trigonometric ratios. So I didn't know going through this lesson, taking notes for and everything, but I still quite don't understand some of the questions. So here, let me
Okay.
put the first one in here.
All right. So this one you're trying to find x, and it's really no different than the ones we've been doing. You're going to use sine, cosine, and tangent. Why don't you try solving this one on your own and letting me know what you come up with.
All right, so I got 22,417
Okay,
as X, so that'd be,
very good.
yeah.
All right. All right. Hey, we're gonna go ahead and stop here for today, Karthik. I know we got another lesson later on, so we'll just pick